All right. Hello. So today's lecture is going to be from the notes for 4.1, General Properties of Aqueous Solutions. So this part in or this chapter is all about creating solutions, which essentially is where uh, you take a what's called a solute, okay, which is a substance being dissolved in a solvent to form a solution, and you dissolve it, like it says, in the solvent, which is the substance present. It says normally the substance present in the greatest quantity. Um, I usually think of it as the second part here, the dissolving medium of a solution. So you dissolve salt in water. Salt is the solute, water is the solvent. Okay. Um, all right. An electrolyte. An electrolyte is a substance whose aqueous solutions contain ions. So, for example, sodium chloride, like I just said, table salt, NaCl. Table salt um, this is an ionic compound, right? So, when you put salt into water, it dissociates, also referred to as ionizing or ionization. So, dissociates, dissociation, ionizes, ionize, ionization. An ionic compound dissolving in a solvent into its component ions. So what happens is in ionization, you have something like sodium chloride, right? And now you guys get to enjoy my wonderful drawing abilities here. So you put it into a kind of okay, you put it into a beaker of water, and what happens is it dissociates in the water, and you get the subsequent ions, Na plus 1 and Cl negative 1. So this is known as dissociation or ionization. Okay. The substance splits into ions in the water. Now, this does not mean that it's a chemical reaction or that it's still not NaCl. It still is. It's just dissociated in the aqueous solution. Um, the best sort of analogy I can give for this is if you imagine like you go to a party with a friend, okay, and you guys go together in the same vehicle, whatever. You show up to the party together, and at the party you hang out, but you're not like next to your friend the whole entire time. Okay, you and your friend you mingle, you talk to different. So sometimes you're together hanging out talking. Sometimes you are with different groups talking, just whatever happens during the party. But then at the end, you're going to leave together because you came together. So that's sort of like what happens to these. These are like friends at a party. They come together. When they enter the water, they mingle they're still around each other and stuff, but they're mingling with everything else. They're kind of separated and mingling a little bit. But if they were to quote unquote leave the party, in other words, if you were to like, say, boil off the water, they would leave together. The salt would still be together if you removed it from the water. Okay, that's how dissociation or ionization works. Okay, all right. Non-electrolytes. Non-electrolytes are substances that do not form ions in solution. Okay, so I should say electrolytes over here. Electrolytes will dissociate. Okay. Now, non-electrolytes, I should have put that over here. I'll get rid of it over there later. Okay, non-electrolytes do not dissociate in water. So sugar, I used C12H22O11 is like table sugar. Let's see. C12H22O11. Okay, so typically your electrolytes are ionic compounds. Non-electrolytes typically are covalent. Okay, you put this into water. Okay. So you put this into water, and what you're going to end up with is actually just the exact same thing. It stays together. Okay, now this is where sometimes people get confused. Okay, sugar will dissolve in water, what we call dissolve, but it will not dissociate. Okay, non-electrolytes do not dissociate. They stay together. Okay, so if I go back to the party analogy, this would be like a couple, that comes to a party, and that they come to the party, they mingle with people, they talk with people, whatever, but for the most part, like, they stay together. They don't really separate. They're always kind of like together as a couple, talking to people or moving around or doing whatever. They don't really go their own ways or do their own thing. They kind of like, they stay together while they're at the party. And when they leave together, obviously. That's kind of like sugar. Okay, like non-electrolytes. When they come, it sticks together. They don't get separated or dissociated. Okay, so solvation, not salvation. Solvation. not like being saved. It's the clustering of solvent molecules around a solute particle. So solvation is essentially what causes dissolving. Okay, so in a um, so what happens is you have your molecule. So let's just say well, yeah, we'll use sugar since I already used it up here. So when sugar molecule, so I'm just gonna do CHO as my sugar molecule, all right, just to keep it easy. So what happens is when this enters water, the water molecules cluster around it. Okay. And what happens is the water molecules like get in between and cluster around the sugar molecules. And what that causes to happen is it keeps the sugar molecules far enough apart that you can't see them. They're still there as sugar molecules. They haven't chemically reacted. But the water gets in between them and essentially separates them far enough apart that you can't see the individual sugar molecules. And that is really, this is what happens in dissolving. Not dissociation, but just dissolving. Okay. So the clustering of solvent molecules around a solute particle. So solvation happens whether it ionizes or it doesn't. Okay. All right. Moving on. Molecular compounds in water. Usually when dissolved, the intact molecule is dispersed throughout the solution, a non-electrolyte. So that's what we were talking about here. Doesn't dissociate, but it's dispersed throughout it so you can't see the individual particles. So it's dissolved for a non-electrolyte. Some molecular substances do contain ions in solution. So one of those are acids. Okay. Acids are technically considered molecules, not ionic. However, like if you recall back to when we made them, we made them as if they were ions, and they ionize in water. So you put something like HCl into water, okay, and that's going to split up into its requisite ions, H plus and Cl minus. You take something like, I don't know, sulfuric acid. Okay, that will break up into, it will ionize into H plus and the sulfate, SO4 2 minus ion. Okay. So that's molecular, but an acid does ionize. Okay, moving on. Electrolytes. We can designate electrolytes as strong or weak. Okay. Now, strong or weak has nothing to do with how soluble or how it dissolves. It, like, if it can or not. It has to do with dissociation. Okay, remember, dissolving and dissociation are two different things. So strong electrolytes are solutes, a solid thing that exist in solution completely or nearly completely as ions. In other words, they almost entirely ionize. Okay. So what are things that are considered strong electrolytes? All soluble ionic compounds, a few molecular compounds like hydrochloric and many other acids. Okay, so there's an equation for a strong electrolyte ionizing in solution. So I'm going to use HCl. So we have HCl aqueous because it's going to be in solution. So when it goes into solution, it turns into H plus aqueous, because it's still in the solution, plus Cl negative aqueous. Okay, this is just showing the ionization in water in solution. I put this in bold. The absence of a reverse arrow indicates that the reaction only occurs in one direction while in solution. In other words, when you put this into water, it splits up into H plus and Cl negative and stays that way. Okay. All right. Weak electrolytes. Weak electrolytes are solutes that exist in solution mostly in the form of molecules, with only a small fraction in the form of ions. Okay, so for example, acetic acid. Most of the solute is present as acetic acid molecules, only a small fraction as the ions. So if I were to draw this out, so the first, actually, let me zoom out here a second. The first thing I'll do actually is I'll do a strong electrolyte diagram here. So in a strong electrolyte, in the, hold on, I'm gonna have to pause for a second here. All right, so I'm actually going to stop the video here because school's getting ready to start, and I'm worried that if I just leave it paused, it'll mess up, and I don't want to redo all that. So I'm going to do the notes in two sections. So you'll obviously, when you'll have already looked at this, you'll see a part two up there. So I'll pick up here in the second section, and we'll finish the notes with that. All right. See you guys in a little bit.